Start, sir.
Okay. So, good evening, participants. Hope you are enjoying the course, and the course is going to end very soon. After that, we will have exams. So, till now, I think we have not received any question from the participants. So, let me discuss first the certain important points regarding the examination, because examination is going to be there within next 15 days or like that. You should remember certain formulas, certain like for the Laplace transform, the basic functions, I will say, like what is the Laplace transform of polynomial function, or the Laplace transform of exponential function, Laplace transform of some well-known trigonometric function, or hyperbolic function, like that. You should remember certain things you have to remember, then you can work out the examples very fast, because although we have derived the Laplace transform of all the well-known functions, but if you remember, it will be better for you. It will be less time consuming whenever you are trying to solve a problem. So the first thing what I will tell is Laplace transform of some basic functions like polynomial function, exponential function, trigonometric function, hyperbolic function, like that you should remember. Then obviously I'm just going from the beginning itself, because this is the last live session. So I'm going from the beginning. Then the first and the second shifting property of Laplace transform, the change of scale property of Laplace transform, Laplace transform of first derivative of the function, that is f dash t, of a function ft, Laplace transform of double derivative of a function, that is f double dash t. This is very, very important, I will tell. So please remember what is the Laplace transform of f dash t, what is the Laplace transform of f double dash t, that you should remember, because not only for solving problems, but whenever you are trying to solve the ordinary differential equation or partial differential equations, they are also the Laplace transform of f dash t and f double dash t will be very useful. Similarly, the Laplace transform of multiplication by powers of t, you should remember. Definition of some well-known functions like Dirac delta function, what are the properties of Dirac delta function, Heaviside function, or what we say unit step function, Laplace transform of these and their properties, the Dirac delta function, Heaviside function, you should remember. Then, but please note that in most of the cases, if you have some difficult formulas, the difficult formulas will be provided in the question paper itself as a hint. But there are certain things which you have to remember. As I told you, the Laplace transform of some functions you should remember always. And also, you should remember the formulas for A0, AN, BN, CN, like this for Fourier series. And now, first part I talked about the Laplace transform. Our second part was in the form of Fourier series. So please remember the formulas, how to calculate the coefficients A0, AN, BN, and Cn if it is complex for a Fourier series. Also, be careful about the denominator for the existence of any singularity. So, for the existence or for any singularity, please careful what is the value in the denominator. Parseval's theorem, you should remember that there is a lot of use of this. Now, come to the Fourier transform. The definition of Fourier transform and the inverse Fourier transform, you should remember. Although we have mentioned it in the last live session, but again I am mentioning this for the definitions of Fourier and inverse Fourier transform. Please note that the kernel what we will use, kernel for Fourier transform, you please use e power I alpha x, and the kernel for inverse Fourier transform e power minus I alpha x. So the solutions, whatever has been prepared, it has been prepared on the assumption of this, that kernel for Fourier transform will be e power I alpha x, and kernel for inverse Fourier transform will be e power minus alpha x, e power alpha x, so that Fourier transform of fx will be 1 by root 2 pi minus infinity to infinity fx e power I alpha x into dx. So please note that whenever you are evaluating the Fourier transform, please use the kernel for that as e power I alpha x. So that Fourier transform of fx equals 1 by root 2 pi minus infinity to infinity fx e power I alpha x dx. And similarly, inverse Fourier transform of capital F alpha equals to 1 by root 2 pi minus infinity to infinity capital F alpha into e power minus I alpha x into d alpha. So please note that for evaluation of the Fourier transform, you use the kernel as e power I alpha x, and for inverse evaluation of Fourier transform, e power minus I alpha x. Now, please remember the modulation properties of Fourier transform, and of course the definition of finite Fourier transform, finite cosine transform, finite sine transform, you should always remember. Because if you try to evaluate all these things, it will take a lot of time and it is time consuming also. So please, before the exam, please remember all these things. And also the basic definition of Marine transform and jet transform, because we have covered mostly these things: Laplace transform, Fourier series, Fourier transform, Marine transform, and the jet transform. Now, in terms of question paper, if you see, there will be total 38 questions. Please remember, there will be total 38 questions. Out of this, your 30 questions will be of 2 marks each, and 8 questions will be of 5 marks each. This, each of the 5 marks question, that is 8 questions which are of 5 marks, each 5 marks questions will have 3 subparts. They are linked effectively, and the marks distribution is 2 plus 2 plus 1. So please note this thing, that each 5 marks question will be in the, there will be 3 subparts, and the marks distribution will be 2 plus 2 plus 1, and these 3 are the linked questions. So please note that total there will be 38 questions. Out of that, 30 questions will be of 2 marks each, and there will be 8 questions of 5 marks each. And out of the 8 questions which are 5 marks each, there will be 3 subparts, and the marks distribution will be 2 plus 2 plus 1. Approximately the subject-wise marks distribution will be something like this. For Laplace transform, it will be 35% to 38% questions will come from Laplace transform. From Fourier series, 12% to 16% questions will come. From Fourier Transform, 35 to 38% questions will come. And both from Marine Transform and Jet Transform, it will be around approximately 8% to 12%. We are saying the approximate distribution. So accordingly, if you wish, in that case, you can give the importance of this. So please note that Laplace transform and Fourier transform will have more than 70% weightage. So you should go through these things properly. Fourier series will have 12 to 16%, and the Marine transform and Jet transform will have 8% to 12% of this. So I hope it's a little bit clear that which formulas, which definitions you should remember from the Laplace transform, Fourier series, Fourier transform, and the marks distribution of the questions, total number of questions, whatever is there. Any question is there? I will just go through one question. Suppose we want to solve this problem. Y double dash plus 5y dash plus 6y equals delta x. Y and y dash approaches 0 as x approaches the plus minus infinity. I have to solve this problem, and it is given that if possible try to use the Fourier transform for this particular problem. Now your function is this y double dash plus 5y dash plus 6y equals delta x. So obviously, since it has been told, so you take Fourier transform on both sides of the given equation, so that you will obtain Fourier transform of y double dash plus 5 Fourier transform of y dash plus 6 into Fourier transform of y equals Fourier transform of delta x. This you have to remember. As I told you, y dash, y double dash, the Laplace transform, Fourier transform, you should remember. So Fourier transform of y double dash is nothing but minus I alpha whole square of y alpha, where y alpha is the Fourier transform of yx. Now Fourier transform of y dash is nothing but minus I alpha into y alpha plus 6 into Fourier transform of y is y alpha, and Fourier transform of their delta function is 1 by root 2 pi. Again, this we know it. So where your y alpha is nothing but the Fourier transform of yx. So after taking the Fourier transform, so now you can keep it in terms of alpha square, and you can obtain y alpha. This is equals 1 by root 2 pi into 1 by I square alpha square minus 5 I alpha plus 6. So this again, if you just make certain calculations, you can write down y alpha is nothing but 1 by root 2 pi 1 by I alpha minus 3 minus I alpha minus 2. That means you are breaking it into 2 parts, and after that you are breaking this one. So that your yx from here, so please note that you have the equation y double dash plus 5y dash plus 6y equals 0. you are taking y alpha equals to Fourier transform of yx and taking the Fourier transform on the both sides of alpha, you are obtaining y alpha. So that now if you take the inverse Fourier transform, you can find out what is the value of yx. So yx, you can write down 1 by root 2 pi, Fourier inverse of 1 by I alpha minus 3 minus 1 by root 2 pi, Fourier inverse of 1 by I alpha minus 2. So now I have to find out these two things. One is the Fourier inverse of 1 by I alpha minus 2 and 1 by I alpha minus 3. And if you see, both are almost similar. That means effectively now I have to find out what is the Fourier inverse of A minus I alpha type of thing. A minus I alpha or the other way around, same thing we will obtain. So Fourier transform, we want to find out Fourier inverse of A minus I alpha. So effectively I am doing the other problem also now. Now, Heaviside function, you know it, hx equals 1, x greater than equals 0 and 0 for x less than 0. So we can assume that fx equals hx into e power minus ax. Obviously, a has to be greater than 0. So Fourier transform of fx, this equals, you can write down Fourier transform of hx into e power minus ax, so that Fourier transform of fx, if you just evaluate it, Fourier transform 1 by root 2 pi minus infinity to infinity hx into e power minus ax dx. So from the Heaviside function hx, for x less than 0, the value of hx is 0. So this equals, you can write down 1 by root 2 pi 0 to infinity e power minus a plus, sorry, what I forgot to write down here, into e power I alpha x, the constant will come. So e power minus ix into this is 0 to infinity e power minus a plus I alpha x into dx. So I think you can evaluate the integral very easily. E power x format is there. So I'm just writing the integration value, that is 1 by root 2 pi into 1 by a minus I alpha. So that Fourier transform of hx into this one, e power minus ax, this is equals this one. So you can write down hx into e power minus ax. This is equals to 1 by root 2 pi Fourier inverse of 1 by a minus I alpha. So what you are getting here, Fourier inverse of 1 by a minus I alpha is nothing but root over 2 by pi hx into e power minus x. So once I receive this one, then I think very easily you can obtain the result of this one, because Fourier inverse of 1 by I alpha minus 3, Fourier inverse of 1 by I alpha minus 2, these two values you can obtain directly from this result. So that you can write down actually your yx as minus 1 by root 2 pi Fourier inverse of 1 by 3 minus I alpha plus 1 by root 2 pi Fourier inverse of 1 by 2 minus I alpha. And just straight away put the result what we got in the last one, and you can obtain the value of yx as hx into e power minus 2x minus e power minus 3x. So if you can see that from the result itself, that e power minus what is the Fourier transform of fx, where fx is nothing but the hx into e power minus ax. From there, you can obtain the result very easily. What was the question? Sumit has asked a question. Please check the answer of the assignment of question number 10. Assignment 10, question number 6. The solution for UXT using Fourier sine transform satisfying for del square u del t square equals del 2u del x square. 0 less than x less than infinity, t greater than 0. Conditions are given u0 t0, ux0 sine 2x. Del u del tx0 is cos 2x. U and del u del x approaches 0 as x approaches infinity. Sumit, as far I remember, the problem seems to be fine. However, we will again recheck this solution and the answer also. As you are suggesting, we will recheck it definitely and post it in the forum in case there is any error. So please note that I think the problem is fine, but we will recheck it and we will get back to you in forum if there is any error. If you have any other doubt, you can just ask us. Any other question is there? Since no other question is there, let me just solve some different type of problems which will give you the flavor that what we can do for this one. Let me see. Suppose, let me write down the question first. If fx satisfies the integral equation 0 to infinity fx cos alpha x dx equals sine of b alpha minus sine of a alpha divided by alpha. Then f of a plus b by 2 is value is what? Where of course it is given 0 less than a, 0 less than b. And if you see a hint, something like will be given, as I was specifying. If there are difficult formulas, then some hint will be provided, like here, sine of alpha x cos of alpha x by alpha d alpha, which is pi by 2 when legs by between 0 to k, actually sine of k alpha into cos of alpha x d alpha and 0 whenever x greater than k. This is given to you and we want to find out the evaluate the integral equation is given 0 to infinity fx cos of alpha x dx equals sine of b alpha minus sine of a alpha by alpha. Let us multiply the both sides of this given equation by root over 2 by pi, so that you can write down root over 2 by pi. You see, the form itself suggests that the integral equation on the left hand side of the integral equation can be written in terms of Fourier transform. Fourier cosine transform, not Fourier transform. So if I multiply both sides with root over 2 by pi, you will obtain fx cos of alpha x dx. This is equals root over 2 by pi into sine of b alpha minus sine of a alpha by alpha. So your left hand side simply I can write down Fourier cosine transform of fx equals this one root over 2 by pi sine of b alpha minus sine of a alpha by alpha. So from here, what is your fx? Fx you can write down root over 2 by pi Fourier cosine inverse Fourier cosine transform of sine of b alpha minus sine of a alpha by alpha. So once I am getting it, so Fourier cosine inverse you can write down in terms of integral, and you can write down your fx as root over 2 by pi into root over 2 by pi 0 to infinity sine of b alpha minus sine of a alpha divided by alpha into cos of alpha x d alpha. So your fx you can write down. I can break it into two parts, two integrals. So this equals 0 to infinity sine of b alpha cos of alpha x by alpha d alpha minus 0 to infinity sine of a alpha cos of alpha x by alpha into d alpha. So please note that the integrals which you have obtained, those are given as an hint. The values of those integrals has been, you see this one, this has been given as hint. So this you have to catch actually, that whatever value is given, how to bring that integral. So to bring that integral of that form, effectively you are taking first root over 2 by pi Fourier cosine transform, and from there you are obtaining inverse Fourier transform, and then you are getting these two equations. So this equals, you can write down 2 by pi into pi by 2 into, I can write it gbx minus gax, where you can define the function as gkx equals 1 when 0 less than x less than k, and 0 when x greater than k. So that your fx is becoming nothing but the function gbx minus gax. Now, what you have to find out? You have to find out f of a plus b by 2. So that when x is your a plus b by 2, then you can write down 0 less than a plus b by 2 less than b. So that it is at x equals a plus b by 2, your fx is nothing but 1 minus 0. So that from here you can tell f of a plus b by 2, the value is equals to 1. So to evaluate one particular integral, if you see, then what of the hints has been provided to you, that you have to check first, and from there you can find out the solution over there. Any other question, anything is there? Let me discuss one more problem. on Fourier transform. Suppose it will look like a very complicated problem. Conditions are given like this. And of course, u and its derivatives approaches 0 as x approaches infinity, y approaches infinity. Some hint is given like this. Fourier sine transform of this equals alpha to the power 4 u bar is alpha y, and Fourier sine transform of u xx yy equals d square u bar is dy square. So it looks like the problem is very complicated, but since it is given that Fourier sine transform of these two are given, so obviously from where you will start? You will start with the Fourier sine transform with respect to x on the both side of this given equation. Since in the hint it is given Fourier sine transform of u xx equals how much, or Fourier sine transform of u xx yy is how much. So therefore, we will take the Fourier sine transform on both sides of the given equation. So what you will obtain? If I take the Fourier sine transform, then I can write down Fourier sine transform of u xx plus 8 into Fourier sine transform of u xx yy plus Fourier sine transform of u yy equals 0. So now taking the hint, already it is given what is the value of Fourier sine transform of u xx. From there, you can simply write down this is nothing but 16 alpha to the power 4 u bar s plus, from this also I know what is the value, 8 into minus 8 alpha square d2 u bar s into dy square plus Fourier sine transform of u yy. This is directly you can write down d4 y bar s by d y to the power 4 equals 0. So that you are getting one ODE. Basically, the problem is being converted into the ODE of the form d4 y bar is dy to the power 4 minus 8 alpha square d square y bar is by dy square plus 16 alpha to the power 4 y bar is, this is equals 0. So now you can find out u bar is alpha y. From here, you can find out the auxiliary equation, you can find out the value of m, and you can find the solution from here. U bar is alpha y is how much? Then use the conditions. Once you are using the conditions, you can find out the values of the constants. Most probably there will be 4 constants, A, B, C, D. So using the conditions, you find out the values of this, and you can find out what is U bar, S alpha Y, and then from there, using the inverse composition, you can find out U x y, which I think you can do it of your own now. What I want to say is that whenever hints are being provided, then try to utilize them as far as possible to find out the solution of the equation. Anything else is given? Hmm? So this we done on Fourier transform, Fourier sine transform. Let me take another example. If finite Fourier sine transform of fx is, I'm denoting FSL, cos of n pi by 2 plus cos of n pi divided by n square pi, x lies between 0 to 2. Then what is the value of in f1? So it is given that finite sine transform of fx is given fsn, and you have to find out what is the value of f1. So once fsn is given this, from the definition you can write down your fx as nothing but 2 by 2 will come over here, summation n equals 1 to infinity fsn into, it will come sine n by x by 2. So from the definition of finite Fourier sine transform, I can write down fx equals this thing. So this is nothing but your fx is, this portion will be cancelled, so that you can write down n equals 1 to infinity cos of n pi by 2 plus cos of n pi divided by n square pi divided by n square pi into sine of n pi x by 2. And what you have to do, you have to find out for x equals 1, what is the value of f1. So that on this series, you put the value of x as 1 and try to find out what is the value. So your f1 you can write down summation n equals 1 to infinity cos of n pi by 2 plus cos of n pi divided by n square pi into sine of n pi x is 1, so it will be n pi by 2. So now I think you can break it into 2 parts. 2 summations will come over here, and ultimately if one you can write down in the form of 1 by pi summation n equals 1 to infinity minus 1 to the power n by n square into sine of n pi by 2. Because both cos n pi you are writing and this one you can write in terms of sine n pi 2. So now you can evaluate the integral. In terms of n pi by 2, always you can write down pi by 2, 2 pi by 2, 3 pi by 2, like this way. You can expand this particular series. And all those terms, like whenever you have sine 3 pi by 2, that you can convert it in terms of sine pi by 2. In sine 5 pi by 2, also you can convert in terms of sine pi by 2, so that you can substitute the value. So that I am not writing. You can obtain this series as like this: sine pi by 2 by 1 square minus sine pi by 2 by 3 square plus sine pi by 2 by 5 square, like this. And just put the value of sine pi by 2, so that ultimately you will obtain 1 by 1 square minus 1 by 3 square plus 1 by 5 square. This series you will obtain. So whenever there is a problem, try to find out the solution in simple fashion. So again, here you have to remember what is the Fourier sine transform, so that from the Fourier sine transform, you can just put it in terms of series, expand the series, write it in some sine function whose value is known to you, and from there you can use this to obtain the result. Satish Sawale has asked a question: how this course will be helpful for GATE ECE preparation? Now, whenever you are doing ECE as a subject, there you are for solving different problems, engineering problems of ECE. You are frequently using not only in electronics but electrical also, all this Laplace transform, Fourier transform to find the solution of your problems. And by that way, it will be helpful to solve the problems of ECE or electrical or mechanical using these transform techniques, that is Laplace transform, Fourier transform, Mellin transform, like that. So directly it may not be helpful for GATE preparation, but it will be helpful to solve various other kind of problems using these mathematical methods. That is the usefulness of this. If you are a student of electronics, then you will see that when you are going through various subjects of ECE, all these are very, these methods are useful. Any other question, anything? So let me just take one more problem and then we will stop if there is no other question. We want to find out the Mellin transform of this function. So we want to find out the Mellin transform of this function. So suppose your fx is equals to this thing, x4 Dirac delta x minus 3 plus x cubed into this. So Mellin transform of fx, this you can write down Mellin transform of the function fx I can break it into two separate functions, so that x4 delta x minus 3 plus Mellin transform of x cubed delta x minus 4. So using the definition of Mellin transform, this I can write down 0 to infinity x to the power x minus 1 into the function that is x4 into delta x minus 3 dx plus 0 to infinity x to the power s minus 1 into x cube delta x minus 4 into dx. So this equals, you can write down 0 to infinity x to the power s plus 3 into this one plus 0 to infinity x to the power s plus 2 into delta x minus 4 dx. So again, if you write down this thing, the value of this, it is directly, you can use this formula 0 to infinity fx into dr delta x minus a dx. This is nothing but fa. So if you use this thing, then directly you can write down it is nothing but 3 to the power s plus 3 plus 4 to the power s by 2. So like this way, you can evaluate the integral over here. Again, Satish has asked another interesting question. How to prepare maths for GATE? So first see the syllabus. What is the syllabus of the GATE? What are the major topics has been given? Try to find out the percentage of questions come from different topics. That you can analyze if you just go through the previous GATE papers, that what is the percentage of questions are coming of overall from the GATE question paper. Then you try to find out, because it may not be possible always to solve the 100%. According to your strength, you choose the subjects where you are most comfortable. Please note that, where you are most comfortable. First, go through the paper, go through the subject, that particular topics. So break it into topics wise, the entire syllabus. Go through the topics of your interest. Now what you do? You try to find out the solution of the previous GATE papers. You solve the previous GATE papers, and it will not only help you to get the different kind of problems, but also that time management also you will be able to do it. That how much, and it will build your confidence that for the previous GATE papers, I am able to do this much percentage and like that way. So please go to the micromanagement, that is go divide it into different topics, and each topics you should decide on which topics you will give more importance, and in the exam also first you will attempt questions from which topics, and like that way you please prepare, so that I think you will be definitely able to crack this. But be systematic, use the systematic approach for that. Any other things there? So this, are you satisfied, or you have any other question on this? Anything you want to say, or are you satisfied? Hmm? No, that only I am asking. They can write it into. Do you have any other query, anything? So this, even if you have any other query, you can just post it in the forum also, and our TAs will answer the questions. So if there is no other question, I think let's stop here. Again, I wish to thank all the participants of this particular calculus course, and wish you all the best for the coming examination. And I hope that you all will get really good grade. Thank you very much.